So, let us continue with the analysis of circuit by using the concept of graph theory. Okay. Now, today last time we found out the loop currents of a given network. Now, today I will take another example to show you how to solve a network problem by using say nodal method and graph theory. So, let us draw the circuit first. The circuit is supposed like this. Okay, like that, and here is also a resistance. And here is a 10 volt source. Here is a 1 ohm resistance. It is connected there. And this is a 5 ohm resistance connected, this is 2 ohm connected there, and here is a resistance in series with a source, and suppose this is plus minus 8 volt and this is 2 ohm, and this is a 4 ohm resistance, and this is a 4 ampere current source. So, this is the network. How many nodes are there? 4, A, B, C, choose this to be 1. So, what I want to do? I want to find out the node voltages that is V n. What is this V n? It is equal to V A 0, V B 0, this column vector V C 0. If you know the node voltages, you have solved the circuit, other parameters being known. So, I want to find out this node voltages using graph theory. So, first thing is I have to draw a graph of this network, which will be like this. This thing you see, this is a branch where the current source resistance. So, this I will show by a single line. This also I will show by a single line. This is also a single line like this, and these two are joined this way, and then you, this is the tree of the network. Name them. This is A, this is B, this is C, this is O, and I want to make a directed graph. The assumed direction, directed means here the current directions. So, assumed direction of current is my choice. So, I will do it like this, and I have to name also the branches. So, let me do that. So, this is suppose I call 1, this I have put arrow this way, 2, this 5, this numbering is also arbitrary, 4, and this is 6, element 6, and this is suppose 3. So, all directions have been assumed and it has become a directed graph. Okay. Now, the first thing is, since by node voltage method, so A matrix is to be known. Recall that to solve these node voltages, what are the things you have to do? You have to adopt this method. So, nodal method means you have to do like this is the A matrix. A y A transpose V n, node voltages I want to find out. So, I must form the A matrix. A matrix formation is one of the simplest among A, B and Q. The total graph you go at each junctions this nodal. So, A matrix for this one will be at node A and all the elements will participate. So, 1, 2, 3, 4, 5, 6. Come to node A, anything coming out of this will be assigned plus sign, is not. So, 1 is plus, 4 is also plus coming out and 6 is plus. These are the only 3 elements which participate in deciding the currents which are coming out there. So, this is the thing, others entries will be 0. Similarly, come to node B. So, this is at node A, at node B you come out. So, 2 is plus coming out from the node and 4 and 5 are involved, but they will be coming in. So, negative. This will be this and finally, at the node C, it is reduced order incidence matrix A. No point in trying to write down the KCL at node O, it will not give any new equation, you know that, and other entries will be 0 like this. At node C, 3, 5 C, 3 and 5 coming out. So, 3 is plus 1, 5 is plus 1 and 6 is minus 1 and all others are 0. So, A matrix is known, therefore, I can calculate A transpose etcetera. So, A matrix is the first thing we do. Then what I have to do is this, I have to get this Y matrix, admittance matrix. What it is? Very simple, Y. It will be a diagonal matrix. Okay. So, the first element will be, which one I have called 1? This one, where there is 2 ohm is present. So, it will be half, is not Y matrix. So, Y matrix, these elements will be half and others are 0, 1, 2, 3, 4, 5, 6, there are 6 elements. Similarly, element 2, this one, here resistance is present, yes, 4, 1 by 4. Third, that is this element is third, that is 1 present. So, this 0, 0, 1 third, no 1 by 1 and then 0, 0, 0. Then the fourth element here it is 2 ohm. So, 0, 0, 0 half, this is the element 4. Fifth element is this one. What is the value? I did not write, I am giving you the value here, which I forgot to write. It is 0.5 ohm, it was giving. So, one, 2, 3, 4, then 5, 2, 3, 4. Fifth element is 1 by 0.5 and 0. And finally, the element 6, which is 5. So, 0, 0, 0, 0, 0, 1 by 5. So, this is the Y matrix. Only diagonal elements will appear. So, it is there. Therefore, the left hand side, this equation, if you go, I am in a position to compute A, Y, A transpose. A is known, Y is known. So, using these two, you calculate A, Y into A transpose. That is all. Then I have to know, so A, Y are known and I s and V s are to be known now. First, let me write this IS. It will be a column vector. In node 1, is there any current? No. In element 1, no current source. Element 2, yes, there is a current source 4 ampere. So, that will be 4 element 2. Should it be plus or minus? That you have to decide. So, it will be minus, is not consistent with. So, plus 4 you write, and then in no other elements there is any current source. So, other entries will be simply 0. Okay. So, this will be your IS. Then I write what will be Vs. It will be also a column vector, and Vs will be equal to, go to each element, see voltage source is present. See, element 1 there is a voltage source 8 volt, and 8 is connected to node A. This is the element direction. So, it will be plus 8. In element 2, no voltage source. So, that will be 0. Element 3, there is a voltage source which should be plus 10, is it not? Plus 10. Element 4, 5 and 6 have got no sources. So, other 3 will be 0. So, this is the Vs matrix. Therefore, I now know everything of this equation. I will calculate A y A transpose. I will just give you the final result. So, this equation I am putting the numbers. If you put here, I am writing A y A transpose. You can verify if I have made any mistake, that is, you check that. It will look like 1.2 minus 0.5 minus 0.2, then this one minus 0.5, 2.75 and minus 2, and this is minus 0.2, minus 2, 2.0, 3.2. This equation, this into VAN. What is VAN? VA 0, VB 0, VC 0. And right hand side will be A into IS. If you do that, it will translate into 0, minus 4, 6, 6 or 0, I think 0. A into IS and A into Y into Vs comes out to be finally 4 minus 4, 10. Got the point? A into Y into Vs. Therefore, these two can be added, is not? Just adding this, it will give you. So, right hand side is a column vector 4 minus 8 plus 10. Therefore, V n, this node voltages, that is this column vector V A 0, V B 0, V C 0 will be this matrix inverse, that is this matrix. So, anyway, let me write so that you understand very quickly. Minus 0.5, minus 0.2, then minus 0.5, 2.75, minus 2, minus 0.2 minus 2 3.2. The inverse of this into your 4 minus 8 10, and if you do this calculation it will come out to be 646. So, I will say look here V A 0 of this network is 6 volt, B B 0 will be equal to 4 volt and V C 0 will be equal to also 6 volt. That means, in this network there will be no current in this branch. So, anyway, after we have got that, I can easily calculate the louder, do not worry. So, these are the step by step one has to go to find out the currents. This is 4, oh this one, this should be 0, there is some correction you just see, 4 0 and 10, this is okay. So, it will be 4 then minus 4 here, please make this correction and 10. So, here it will be 4 minus 4 minus 4 and 10. So, you see you have to take the inverse of a matrix, therefore, that is not very easy. I mean, people often make mistake, particularly if it goes beyond 2 by 2 matrix, but computer will do very easily, and only thing we are demanding is make these simple matrices, that you should do correctly, then give it to a computer. It will calculate and give you finally the node voltages or the loop currents, and from node voltages and loop currents it can be easily you can calculate the every branch currents as I told you earlier. So, this is the second problem where I have it. Of course, you should not be under the impression that I could also apply the fundamental loop method to do this. These I leave it to you. Same for this network I have adopted the nodal method. If I ask you find out the fundamental loop currents, I think you will be able to do, draw a tree, then you have to draw and so on, as explained in the first example. Now, finally, another network I will, for the same network, is not for the same network, we will try to find out the tweak voltages. Let us see. So, the same network. So, let me copy this. Copy, new page, and here I paste. Okay. So, this is the network earlier given and we want to solve it. So, this is the network, this is the graph, all the values are given, directions. I have assumed hopefully same directions you are keeping. Suppose this is the same network, we have to solve it by what is known as solve this, get solve for the tweak voltages Now, tweak voltages, the moment I ask you to solve for tweak voltages, you must understand that I may choose one tree, you may choose another tree. So, the relevant tweak voltages I am talking about, whatever tree you draw, from that whatever tweak voltages are obtained, those I am asking to solve for. So, here in this network, what we will be doing is, first step is you draw the graph of the network, and this you have to do very peacefully. Okay? So, suppose we say that I name the elements 1, 2, 3, and this is suppose 4, element 4, and this is element 5, and this is element 6. Okay. So, element names are also different from that. So, arbitrarily once again graph has been drawn. I name the elements arbitrarily, do not worry. So, 1, 2, 3, 4, 5, 6. Then I have to make a directed graph, that is, we are in effect assuming the direction of the current, which I am allowed to do so. So, this is suppose the direction, this way I assume now, this is 6 and this is 4 and this is 3. Node name I do not change, A, B, C, and this is O. So, if you know why I want to calculate tweak voltages, if I know the tweak voltages, then all other branch voltages can be found out. So, we say that if you know the tweak voltages, you have almost solved the circuit, that is the whole idea. Okay. In this case, I have to choose a tree, because tweak voltage is involved. So, I have to choose a tree. Okay. So, tree I will choose this as the tree. So, all the nodes should be present and they should be connected. So, this is the thing I choose. Okay. That is, this is 1, this is 2, this arrow I forgot to give you 2, and this is 3. This is A, B, and C. So, these are the tweaks 3. So, if you know V1, V2 and V3, that is the target, I want to get that. Okay. And these are the the links. Links also do not play with the directions. Once directions has been assigned, you keep them as it is 5, but at the beginning you are free to choose, that is the whole idea. So, 6. So, all the directions I have shown and things like that. Now, here I have to first form the Q matrix, is not. Now, what is the equation I will be using? First, let me write it down. Equation that I will be using is this one, involving Q, that is this equation. So, I copy this equation, this. And paste it here. So, since I have to calculate the tweak voltages, this equation is of concern. You know, V t is the tweak voltages. In this case, it will be V 1, V 2 and V 3. You know, this tweak voltage is here will be this column vector, matrix VT1, VT2 and VT3. And if you know this, you know everything almost. So, this is the thing I have to calculate. So, before that I have to form this Q matrix. Q matrix, how to form it? You have to basically write down the KCLs at different cut sets, is not? So, what are the cut sets? Cut sets will be wherever you cut this network, there should be only one tweak present, that is the first thing. So, first cut set is this one involving 1, this is the cut set 1. Involving 1, there are several cut sets, here also there could be a cut set, but no, there will be 2 tweaks involved, that I will not do, only one tweak will be present to make a cut set. And then you have to apply KCL at this cut set. So, here the thing will be at cut set 1, I am writing down the KCL. So, direction and here all the elements can participate. So, 1, 2, 3, 4, 5, 6 you write, and then you see the direction of 1, this tweak you assign plus sign from left to right. So, plus 1, 6 and 5 are also from left to right. See 1, 4, 1, 5, 6 are involved. So, this will be also plus 1, is not, and all other will be 0. This is cut set 1. Why I have named it 1? Because tweak 1 is involved. Similarly, I have to make a cut set involving this tweak 2, is not, cut set 2. How this can be done? This I will do it like this. This is cut set 2. Is it a valid cut set 2? Yes, because it involves only one tweak and 1, 2, 3 links. So, valid cut set, and in this cut set 2 I have to write down the KCL at the cut set. So, at this cut set from top to bottom, if you see this decides the plus sign, this tweak directions. So, this is plus 1 tweak. 5, it is also from this side to this side, same as 2. So, 5 will be 1, 4 it will be opposite minus 1 right to left, and 6 will be also plus 1, 0, 0 over, and then cut set 3 involving this element, this tweak, and this will be this one. So, at cut set 3, once again the direction is decided by 3, 3 is from this way to this way. So, that is from left to right. So, it is plus 1, plus 1, then 4 and 6 these are minus. 6 will be plus, yeah, from this to this. So, 6 will be plus and 4 will be minus, sorry this one. So, 3 plus, so 6 is also plus and 4 is minus, 4 is minus. So, this is how Q matrix is formed, and then I have to get the Y matrix. Y matrix as I have done already earlier, is not? Y matrix, this I am not repeating, that Y matrix does not change. Oh, number changes 1, 2, 3. So, let me write, because 1, 2, 3, 4 are changed. So, Y matrix will be, let me write. So, element 1 is this one. So, this will be half. So, all other are 0, 5 entries will be 0. Element 2, I have called this one as element 2. So, 1 by 4, 0, 1 by 4, 0, 0, 0. Element 3, this one I have called element 3. So, this is 1 by 1, others are 0, and element 4 is this one 1 by 0.5, and other entries are 0. And element 5 is this one, which is up. I mean, you can write much better way, 1, 2, 3, 4, 1 by 2, element 5, and finally, element 6. Element 6 is this one 1 by 5. So, anyway, this Y matrix is a 6 by 6 matrix, only diagonal elements are present, Q is known. So, Q Y Q transpose I will calculate. Similarly, I s and V s I can write down. Will it change from this other? So, let me write down. Let I s will be 6 entries will be there, it will be a column vector. So, I 1 nothing is there, I 2 is this one 4 ampere is there, plus or minus this minus 4, then 3 nothing and no other branches. So, these are all zeros, 1 2 3 4 5 6, I s is over. V s will be this column vector, where the branch 1 has got no voltage, branch 1 no voltage, branch 2 no voltage 0, branch 3 yes there is a voltage plus 10 volt, minus 10 volt. Minus or plus? 3. Oh, this is the arrow. So, minus 10 volt, and then V3, V4. V4 is nothing. V5 is plus 8. See, this plus minus you must understand and have practice 1, 2, 3, 4, 5, and in branch 6 there is nothing. Therefore, once you know this, you will be able to calculate. And I am not writing those numbers, and I will tell you that how to do it. So, calculate this in the same way, get the tweak voltages, and after you get the tweak voltages, element voltages can be found out. How tweak voltage and element voltages are involved? Q transpose into element voltages into tweak voltages is equal to element voltages. So, once I know voltage across each element, then I will be able to calculate the currents here and there, other details. Thank you.